Hi, I'm Gena. Today, I'm going to be walking you through how to get from PDFs to a retrieval augmented generation workflow. We're going to be starting with scientific papers on forever chemicals. From there, we're going to extract the text, chunk it, compute embeddings, and then finally, we're going to finish up by building a RAG workflow in AIP logic. Before we get started, a quick word from our founder.
Discover how Palantir customers unlock more value from Foundry and AIP thanks to our live instructor-led trainings. We are Ontologize, a group of former Palantir engineers who love teaching. We've trained thousands of Palantir users at leading organizations around the world. Unlock the full potential of your Palantir deployment by going to ontologize.com.
For our workflow today, we're going to be starting with documents from the UCSF Industry Documents Library. So in this case, I'm looking at reports on forever chemicals, in this case, specifically one forever chemical, glyphosate, just to narrow things down a little bit. So I've just taken all of these PDFs, there's only 9, and downloaded all of them. From wherever you are in Foundry, you're going to navigate to your project if you already have one. If you don't have a project yet, you're going to have to make one. So from here, you're going to hit Control-J, and you're going to search for your project. So mine is called Gena Learning Project. So click on your project. You're going to want to make a new folder for this use case. So I'm going to hit New, Folder, and I'm going to call this End-to-End RAG Workflow. So we're going to click into that. And now make sure you've already downloaded the PDFs or whatever PDFs you want to work with for this problem. So from here, I'm going to hit New, Upload Files, choose from Computer. And I'm going to grab all of these PDFs that I just downloaded. And then hit Open. Now here you have a choice. You can upload as a media set, bundle all files into a single data set, or upload as raw files without modifying the extensions. In this case, you're going to want to upload as a media set. So from here, we're going to hit Next. The latency should be batch, and then hit Upload. And now we've successfully created our media set. So we're going to hit Done. Let's rename this. We'll call this PFAS, Forever Chemicals, Papers. And so now let's take a look at what we have. So if you haven't seen one before, this is a media set. A media set is a way to store things in Foundry that aren't tabular data sets, such as pictures and PDFs, videos, recordings. So the first thing that we're going to want to do is take a look at our PDFs to see if any are not machine readable. So if I take a look at this first one, I can see that it is indeed machine readable. When I highlight the text is recognized. Now, on the other hand, we have this last one, which does not appear to be machine readable. So we're going to have to deal with these a little bit differently. So here we have our PDFs. So each one of these boxes is one PDF, which means there might be multiple pages there. So now what we're going to do is extract the text from the PDFs, chunk it, and then compute our embeddings. So go back to the root. And now from here, you're going to hit New. And you're going to search for Pipeline Builder. We're going to call this Embeddings Creation. And then hit Create Pipeline. Make sure the pipeline type is batch. So here we are in Pipeline Builder. Also, I want to make a note that you can also do this whole process in code repositories. But for today, we're going to be using Pipeline Builder. So from here, you're going to hit Add Foundry Data. And you'll see the PFAS papers, which should be in your folder. And you're going to hit that plus sign to add them. So you're going to hit Add Data. And here you have your media set in your pipeline. So from here, you're going to click on that node. And you'll see an option to transform. That's the one that you're going to want to go with. So you're going to hit Transform. And you only have one option here, which is Convert a media set to table rows. So we cannot work with a media set directly. We're going to have to convert it to a tabular format. So you're going to hit Convert Media Set to Table Rows. Keep these both toggled on, and then let's hit Apply. So now let's take a look at the output table and see what this did for us. So here, the input is being sampled, and our results have a couple of columns. So we have the timestamp, the path. This is also the file name of the PDF. We have the media reference, and you'll notice this is of a different type. It's of the type media reference. And this is a way to refer to this piece of media throughout Foundry in multiple places, in multiple pipelines, without actually duplicating or copying the piece of media. And then finally, we have the media item RID. Every PDF, every resource in Foundry is going to have a resource ID or RID. And so that's what this value is. So let's give this path a name. We're going to call this convert to rows. So we'll close this out. And now we're going to take our next step, which is going to be to extract text from the PDFs. So from here, starting from convert to rows, you're going to hit transform. And before we even get started, let's just give this a name. We're going to call this extract text. And you're going to search for PDF, and then you'll see PDF text extraction. So we're going to hit PDF text extraction. Now, here's where we have to make a choice. So we have the option to do our extract from raw text or via OCR. Extracting using the raw text method only works for machine-readable PDFs. And as we saw, not all of the PDFs in our collection are machine-readable. So in that case, we could, in theory, use the raw text extraction for some of them and OCR for some of them. But for simplicity here, we're just going to use optical character recognition for all of the PDFs. So you're going to hit OCR. And now OCR is going to take in a media reference. So again, that's going to be your reference to that PDF. So here we're going to use this media reference column. And you know it's different because it has this little picture as an icon instead of, say, media item RID, which has a string. So media reference is our property. You can configure the start page to be something other than 1, but we'll keep it as 1 for now. The end page, unspecified. For error handling, we'll keep it as the defaults. For the output format, you have the options text or HOCR. So HOCR is going to preserve layout information. And we don't need that for now, so we're just going to hit text. Now for the languages, I believe these are all in English. So we're going to select English as our language. And finally, we're going to rename the output column to text. And then hit apply. And so now we have our results. And so you'll see that we have this text column, which is an array. And so in this array, every element corresponds to a page. Now, a lot of these PDFs have a lot of pages, and so we're going to want to deal with this. Now, I will note, in this case, we do have a lot of text on each page, but if your PDFs are really, really sparse, if you only have a sentence or 2 on each page, you might not necessarily have to do this step. You could simply turn the array into a string, but you would only really want to do that if your text is pretty sparse. So from here, we're going to search for explode. Now we have a couple of options here. We have explode array and explode array with position. You may have seen explode array before. That just makes a new row for every element in the array. Now we want explode array with position because that means that we're actually retaining the position in the array that the element was pulled from. And that's important because that corresponds to the page number. So from here, we're going to hit explode array with position. Now the array is going to be text, and the output column is also going to be called text. Now we're going to hit apply. And so here we have a result. So you'll notice that we have 87 rows. We'll have 1 row for each page of each PDF. And here our result is a struct. And so here you can see that we've retained the position and the element. So the element is the actual text that was pulled from the page, whereas the position is the page number that it was pulled from. And so now this is a struct, so we're going to have to deal with that before we move on. So from here, you're going to search for extract many struct fields. So you're going to click on this one. And so for the struct, it's going to be text. For the locators, we have position, which is again is the page number. So we're going to call this page. And then we have the element. And the element is the actual text. So now that's our new text column. And now we're going to hit apply. And so here we have our page and we have our text. And now make sure you've applied, and then we're going to close this and move on to our next step. So from here, we're going to move on to our chunking step. So chunking is the process of breaking up our text into chunks so that we can return more relevant pieces of information and also speed up the embedding process. Now, I will note that you don't always have to do this step. Again, If the text on your page is quite sparse, it might not be necessary. That's something that might be specific for your use case. But in our case, we have quite a lot of text on each page, and so we're going to want to chunk the text to make sure that we can return relevant results to the user. So from here, starting from extract text, you're going to hit transform. And we're going to call this one chunk text. So here, you're going to search for chunk string. Chunking the string is something that Pipeline Builder supports natively. So you're going to hit chunk string. And now the expression, the text that we're chunking, it's going to be text. For the chunk size, we can do 256, we can do 512. I'm going to lean towards 512 in this case. Next up, we can configure how much are the chunks supposed to overlap. I like to allow for a little bit of overlap. And also, you can add custom separators for chunking. And so here, we're going to call the output text and then hit apply. So the result of the chunking operation is now we have an array. And so to deal with that, we're going to have to do the same thing that we did before when we had an array, which is to explode it with position so that we can also retain the chunk position. So we're going to search for explode array with position. And the array, of course, is going to be text. The output is named text, and then hit apply. And now from here, we have a struct, and so we're going to extract the fields just like we did before. So we're going to search for extract many struct fields. The struct, of course, is going to be text. The locator, we have position, and we'll call this chunk position. And then we have the element, so that's the actual text again. And we're just going to call this text. And then hit apply. And so now we have multiple rows for every page in the PDF. So now from here, we're going to produce our embeddings. So we're going to hit close. And then from chunk text, we're going to do yet another transform. And we're going to call this one embeddings, plus we're going to do some other finishing touches. And so from here, Pipeline Builder has built-in embedding support. And so we're going to search for embedding, text to embeddings. And so what this embedding process does is the embedding takes the text and produces a numeric vector representation in high dimensional space. So the vector of numbers that gets produced from the text when we go through this embedding process actually captures the meaning of the text, which enables us to do semantic search workflows later on, which of course is core to our RAG workflow. So the text column is going to be the text. And for the model, I'm going to stick to text embedding 3 small. The output mode is going to be simple. And then instead of text, we're going to call this output embedding. And then we're going to hit apply. And here, you'll note that this is just a sample of our data. We have our embedding column. So now we actually have one more thing to do. We're going to be making this an object in the ontology, and so we're going to need a primary key. Now, a natural primary key for this data set is going to be a concatenation of the media item RID, which is one-to-one with a PDF, the page number, and the chunk position. So that will be a unique ID for chunk. So to do that, we're going to search for concat strings. The separator can be whatever you want. I use a dash. The expressions, it's going to be the media item RID, the page, and so you'll notice right in here, it casted the page to a string since we can only really concatenate strings. I'm going to add an item, and it's going to be the chunk position, and you'll see it also cast that to a string. And I'm going to call this output the ID, and then hit apply. So now let's close this out to see what we've done. So again, we started with some documents. We converted the media set to rows. We extracted the text. We chunked the text. And then we computed our embeddings and added a primary key. So the next step is we need to add an output of this pipeline. So we can either add a data set or we can directly create the object type from Pipeline Builder. So let's choose that latter option. So from here, you're going to click on that last node and you're going to click the gold Add Output. And we're going to make a new object type and give this a name. Make sure to prefix it with your name if you're working on a shared stack with other people. So Gena research paper embeddings. And I'll give this a little paper icon. So let's go over the configurations over here. So you'll see that we have the ID as our primary key. So we have a primary key property. That's what that key means. It's also the title key. So the ID might not make the best title key, but it's not terribly important for these purposes. But just keep in mind that going forward, you might want to have a more expressive title key. One option for doing that is actually to use the LLM transform to create a 5-word summary of each chunk. That is one option. And now from here, we're going to hit save and then deploy. Now you're going to get an error. And that's because there's a resource outside this project that we're using in this pipeline. So we're going to hit import resource, and you'll see that it's text embedding 3 small. We have to actually import that model. And so here, we're going to hit add reference, and then we can hit deploy. Now, while this pipeline is deploying, let's take a look at the pipeline outputs and discuss some things that can go wrong here. So something to note is that if you incidentally do leave a struct column in your output dataset, you might see some unexpected behavior in AIP logic. So just keep that in mind as you go forward. And now that our pipeline is deployed, we're ready to move on. So from here, we can take a look at our object and take a look at its configuration. So here's our object configuration. It's already basically been done for us. But I do want to take note that in this embedding property, you'll want to make sure that the model being used is the same one that you configured to make your embeddings in Pipeline Builder, which it is. And so here, we can see that this object is still undergoing indexing by the spinning. And if I look at data sources, then you can see that the pipeline is still running. So we're going to give this a few minutes to make sure it's indexed, and then we'll move on to building our RAG workflow. So now the indexing process has completed, and you can see that we have 816 objects, again, where each object refers to a chunk of text. So from here, we're going to author our logic function. Now, before we do that, it's important to note that AIP logic is definitely not the only way to use these embeddings. You can also, for example, use them to build out an agent using the AIP Agent Studio. But for this purpose, we're going to be building out a logic function. So from here, you're going to hit Control-J, and we're going to search for logic, AIP logic, click on that. And now from here, we're going to hit new logic, and we're going to call this one PFAS question function. And then hit save. And now from here, we're going to add our user input. And so the function input is going to be the user question, some sort of research question that somebody wants an answer to. So here, we're going to add a function input, and we're going to call this the user question. And it's a string. So the first thing that we want to do is conduct a semantic search using this user question to find the chunks of the research papers that are most related. And so from here, you're going to hit semantic search, and we're going to call this relevant chunks. Now, the object set that we're going to be searching, we don't have it in our function yet. So you're going to hit create new object set, and you're going to search for embedding, and you'll find your object type, research paper embeddings. And note here that it created a block for me that basically just invokes this object set. So here we're going to keep filling out our semantic search. So the property to search is going to be embedding, the number of returned objects. It could be between 5 and 10, but it really does depend on your workflow. So in this case, we're just going to say 10. And so the query, of course, which is what we are doing our semantic search on, is going to be the user question. So again, what we're doing here is we're finding the 10 chunks that are semantically closest to the user question. In other words, it's finding the 10 vectors that are closest in high dimensional space to this user question. So let's try this out. So let's ask a question. Has glyphosate, which is the PFAS that we've been talking about, glyphosate been found in wheat? And I'm going to preview run. Now you'll notice I'm not going to get a text answer here. Here, I'm getting a resulting object set. And now if I click on one of these results, say Open an Object Explorer, then I can see the chunk that was found by the semantic search. So this is chunk position 6, page 3. So if I click on the media reference, which is a preview of this PDF, look at page 3, I can see that more than 40% of wheat samples contained residue of this chemical. So that seems relevant. Now I'm going to close this out. So here, this is returning an object set, which is great, but it's not what we want. What we want is a text answer. And so to get that, we're going to need to use a large language model. So from here, we're going to hit Use LLM, and we're going to call this Summarize Answer. So in the prompt here, we have the system prompt, and we have the task prompt. We're not going to be using any tools today. So for the system prompt, that's like the job description. And the task prompt is, what data do you need to do this? So for the system prompt, it would be, you are a helpful research assistant. Your job is to summarize the results of the relevant chunks to create a concise answer to the user question. So that's who you are. That's your responsibility. Now, what data do you need to do it? So we have relevant chunks here. Now, to reference a variable, I'm going to type a /. And so here we have this relevant chunks object set. Now, the problem here is that this is an object set, and we have to feed text into our prompt, not an object set. So when I click on this, it will prompt me to pick a property. Now, the property that I'm going to want, this is what we're going to have the LLM use to synthesize its response, which means we want the text. Add one property. And you'll see that this made me a block above my current block, which basically takes this object set and formats it as a string so I can easily pass it into the body of the LLM. And so here, you can see that the variable that I'm actually passing into the LLM is relevant chunks formatted. Now, of course, we're also going to share with it the user question. / user question. And now here, of course, we can change what model it is, change the temperature. And now I'm going to hit preview run. And so here we can see, yes, glyphosate has been found in wheat. Here's some numbers. And so now that we've authored our function, we're ready to go publish it and use it in Workshop. So from here, you're going to hit save and publish. Make sure your API name is unique, and then hit publish. And so here, let's use our function in Workshop. So we're going to hit open in Workshop. And now we're going to make a new Workshop module. So we're going to hit new module. And we're going to call this demo PFAS answer generator. And then hit save. And so here we only really need to work with one section. So I'm going to get rid of this section on the left. Get rid of the section header. And so what I'm going to have here is I'm going to have a text box for the user to write their question, and then I'm going to display the answer below. So I'm going to hit add widget, and it's going to be a text input, specifically a text area, so that the user has a little bit more room to author their question. We're going to label this research question about glyphosate. Now we have the placeholder. Type your question here. Now the string value, the variable that holds the user input, we're going to call this user question. So from here, now we're going to split the section, add a section below. Going to make it bigger by changing the row height to flex. Hit add widget. And here, you search for logic. You have the option to display AIP generated content, specifically logic generated content here. So you're going to click on AIP generated content. Now, you have a couple of options with this widget, but we're going to stick with the logic option. The logic function is going to be PFAS question function. The function input, of course, is going to be the user question. And so now we can try this out again. Let's ask this time, has glyphosate been found in soybeans? So I'm going to hit run LLM, and it'll run this function under the hood and then display the response here. So here we have our answer, yes, glyphosate has been found in soybeans, with some data to support. So now the other way to use your function in Workshop is you can just have a function-backed string variable. So to do that, you would go to variables, hit the plus sign, make a string variable backed by a function. So I'll call this function backed string example. And the function is going to be, of course, our PFAS question function. The function input is going to be the user question. So this is just another way to use your AIP logic functions in Workshop. And here you could put the result of this function anywhere you want in your app. So make sure you save your app, and then you're done. So in summary, we started with some PDFs. We converted it into a tabular data set. We extracted the text. We chunked the text, produced some embeddings, and then created an object type. From there, we authored a function where we perform a semantic search on those embeddings using the user question, and then summarize the answer using a large language model. Finally, we put it all into Workshop. Thanks for watching. We hope you found this helpful. Let us know what you want to see next in the comments.